So, we know how to do math, we know how to do pictures, we know how to do truth tables, and we know how to do our programming symbols. But what happens if we see a single logic gate with a ampersand or our single line OR? And our single line ampersand is and also our caret XOR gate works this way, and I believe the tilde is the NOT gate for these operators are called bitwise. Bitwise logic. Okay? So bitwise logic, it will do these on a bit level. So if you're doing 7 and 8, okay, you will have to know what 7 and 8 are in binary because it operates on each bit. So 7 in binary is 1, 1, 1, 0, 2, 4, and then the next one's 8. So that's 7 in binary. 1 plus 2 plus 4 is 7. Okay? And then 8 in binary is 1, 0, 0, 0. And sometimes you could see this written as like that. And this is 7 and 8. In this case, we'll look at each individual column to see if they're all AND. So if there's not both ones in the column, we'll put a 0 at the bottom. So in this case, 7 and 8 equals 0 because there's nothing in common between the bits of each of these. But what if we did 7 or 8? We're going to change this all up, and we have to rewrite this entire expression as 7 or 8. This will look like a 1, so I would either write or you draw it like really far away from your previous number, or you may want to draw an L looking shape. And since you have a 1 in one of these columns, you will just put a 1 in all the places below. In this case, 4 ones is 15 in binary when you convert it to decimal. 7 or 8 is 15. That sounds weird. It's not like you're adding 7 and 8, because if you add 7 and 8, it's 15. But what if you're adding 3 or 2? 3 or 2 is not going to be the same result as adding 3 and 2. Let me show you that 3 in binary is 2 ones, and 2 in binary is 1 0. And this is going to be 3 or 2, and you'll see that it'll end up being 3. You don't carry unless you're doing binary addition or subtraction. And in binary addition and subtraction, you just have like, you'll have 3 and 2, and you'll do like 3 plus 2. And since 1 plus 0 equals 1, you put it down there. 1 plus 1, since you can't have a 2 in binary, you'll put a carry over here, and you'll put a 0 here. It's just like adding 6 and 4. 6 plus 4, you turn into a carry, and that turns into 10. Well, 1 plus 1 is technically 2, but in binary, we just carry it over to the next bit. And 2 plus 3 in binary equals 101, which is 5 when we convert it back to our decimal number system. So after doing our bitwise on paper, I wanted to show you that this actually works out in the actual Java language. So I opened up our compiler, and we're going to do our 7 and 8, or our 2 or 3, or 7 or 8. So we're just going to plug in 7 ampersand 8 right on this line of code that says system.out.println, and that will print the output of 7 and 8. So when we click the run button, it'll pop up as 0 right here. And that 0 shows you that 7 and 8 is actually 0. Now if we change this ampersand to our straight line, and the straight line is actually just above the enter key. You have to hold shift and then press the key right above the enter key to get your straight line. And that straight line will be 7 or 8. And that will pop up as 15 right down here. Now, what about 2 or 3? Okay, we said that 2 or 3, we're not adding them together because 7 or 8 was 15 and 7 plus 8 is 15. We're not exactly adding them together. 2 or 3 is actually just 3 because 1 and 0 or 1, 1 equals 1, 1. And 1, 1 in binary is 3 in decimal. So it's going to give us the output of 3.